Hey, welcome back to week 7. This is Yash Edavalli, and we'll be learning about spatial analysis this week. So, as we all know, GIS deals with a lot of spatial data, and some of the data, to turn it into information, we need to actually process and model this data to produce meaningful and decisive results. So to produce this sophisticated spatial information, we have to use methods or tools that process or transform data into information. So in this chapter, we'll be seeing some examples on how to do that. Especially the GIS tools we'll be using would be buffers, which is also called as proximity buffers, and then we'll be talking about site suitability analysis, and then we'll be looking at multiple ring buffers, where we'll be talking about gravity model, and we'll see what these mean and how to actually implement these analysis using GIS. So let's talk about proximity buffers. Proximity buffers is nothing but like the word buffer means, it creates a polygon around the input features to a specified distance. So if you have points, it's gonna create an output, create poly or circles around these points at a certain distance that you mention. If it's lines, it's gonna create polygons based on your distance as well. So there are two different output options. One is dissolve none and dissolve all. So as you can see, it's pretty obvious when you use this dissolve none option. The polygons will be generated for each individual feature. As you can see here, these two polygons, these are two different features. But if you use the dissolve all option, all these buffers which are at the same distance. If you use multiple rings, that's a different issue. But as long as you are just creating one buffer around these will be merged into one single buffer feature. So points, circular buffers will be created, and then lines will be looks like worm based on line feature, and then the polygons, you'll get like a rounded polygon buffers around, cut up with sort of like a cut off edges sort of a thing, because the distance is always maintained from the edge of the polygon. And then let's look at an example. It'll make more sense if we do this. So let's take an example of a polluting company. What you're looking at is in Minneapolis, you have all these polluting companies, and we want to create a buffer of 1 mile around these, and here we are using a dissolve type of all. So once you do that, essentially you create all these zones around these polluting companies where there should be no schools perhaps, or some added measures would be needed for these schools. So once you do that, you would know you can possibly extract data based on these buffer polygons that you just generated by schools. You can generate a list of schools that are too close to these companies, and then you can even get like if you added population, this could be block groups or even addresses. You can essentially get a list of addresses that are within these buffer polygons and might be under potential threat from these polluting companies. So if you're looking at a point buffer example, another example would be crime near schools. If you can create a buffer around the school points, and then probably 300 feet around the school points, and then you would be able to see which schools have the most number of crimes that have occurred pretty close to the school, and you might be able to take additional measures, like maybe added lighting around schools, or maybe increased patrol around the schools to address these issues. So there are several uses to creating these buffers. A line buffer example, for example, you are looking at improving a street corridor. and then you need to notify, or there is going to be a construction project on the street, and you need to notify all the businesses which are about quarter mile from the selected street. So what do? So you create a buffer around this particular street, and then you create a list of businesses, select by location. You do a select by location, get a list of businesses, and then you can probably notify these businesses about, you can call them, or you can send them since we have addresses here, you can probably send them a letter notifying the improvements that are being made and requesting their patients, or making alternative plans, or maybe calling for a public meeting so that they can discuss this. Another way, and you can also join the business points to the buffer polygon and get like a count of total number of businesses that are being affected, so that you know the impact this project would have on this particular street corridor. Again, polygon buffer example, let's say you have a parcel and you are creating a 150 feet buffer around this parcel polygon. So somebody is trying to do some improvements on this piece of land, or maybe put up a building or something, and they would like to know what would be the impact on the surrounding polygons, on property values, and so on and so forth. So what they would do is create a buffer for 150 feet, select all the parcels around that buffer, and then essentially get a list of all the owner names and addresses, and then even they can look at like maybe tax on buildings, what's the average tax that they're paying. You can do several different analysis. This could be used in some kind of a TIF project, or tax increment financing, or a revenue study, or something like that. So anyways, buffers, like I said, have multiple uses. It's a pretty simple tool to use, and it could be very, very useful. So what about a polygon buffer around a river body? So we need somebody is trying to analyze the environmental conditions, or flooding or something. What they need to do is they create a buffer of half a mile, 2640 is half mile, around these river bodies, and sort of trying to figure out what are the schools or colleges, or companies that are in this flood zone, and how they are contributing to the how they should be notified in advance, and maybe come up with a system to address these issues if the river or water bodies flood. So let's go back to the book and actually work on tutorial 9.1 so that we understand how to perform this analysis. So I open my map document from my maps folder, which is tutorial 9.1 document, MXD. What we are seeing is so essentially what we are seeing is assault offenses where they happened in combination with the location of bars. So what the police are trying to figure out is perhaps which bars to sort of like close after a certain time in the night, so that there wouldn't be so many offenses close to them, so on and so forth. It could have multiple purposes again. So what we can do using GIS is create a simple analysis. So just go to click on Windows and make sure you have the Control F search on. So I'm going to click on our toolbox, which is right here, our toolbox, and then click on expand analysis, and then under proximity analysis toolbar you'll find the buffer tool. Double click on that. Once you do that, it's gonna give you this window where it's gonna ask you for your input features, which would be our bars, and then we are creating a quarter mile radius from these bars. So for analysis, 0.25 miles, select the units as miles, and then for the dissolved type you can say you can dissolve all because we don't really need individual polygons for this. So click on OK, and then your buffers will be generated, and you'll have looks like some kind of an error. Never mind, looks like I need to save this into a new okay, I'm gonna redo this. Select bars. I'm gonna save this into my, that's what I wasn't doing before. I was gonna press GST1 under my exercises chapter 9. I'm gonna save this into my GDB. Call it bar buffers. Okay, and select my quarter mile buffer and dissolve everything. Click on OK. So my buffers will be generated and added to the map. So I'm gonna right click on my buffers and click on zoom to layer, and now I'm going to create a hollow outline so that I can see what's going on inside these buffers. So that's my buffer. Maybe if you want to change the color, you can perhaps. So those are your buffers. So what you can do now is now we need to go to selection by locations, and then we're gonna select assault offenses that occurred within the bar buffer zone, this danger zone, so to speak. I'm gonna click on apply and OK. So what I'm going to do is export the selected features data, export them into assaults and bar buffers. Export them as assaults and bar buffers. I'm gonna save it, add it to the map, and then you can turn it off or remove that layer, and then make these assaults maybe give it a big bright color, something like that. Click OK. So now you know where these buffers are, where these crimes have been happening and where they are concentrated. So essentially you can make a case now saying, okay, bars which are close to the most of the offenses, maybe 4 or more or 3 or more or something like that, should be sort of like forced to close down after, I don't know, 1 p.m. in the night, 1 a.m. in the night or something like that. So anyways, you can save your work and move on to site suitability analysis. Site suitability analysis for a facility location is sort of like a classic example. So in this exercise, what we'll do is try and locate a new police station, and we have been given a certain criteria that it must be centrally located within each car beat district, and then within a 0.33 mile buffer radii of each car beat centroid, and then it must be in a retail commercial area, which means it should be within a 0.1 mile of at least one retail business, and it should also meet the criteria of being very close to the major streets, which is a 0.05 miles from any major street. So we will use GIS to actually run all this run this analysis or perform this analysis. So we'll start the map, we'll have police car beats, retail business point, street center lines, and then we'll create a car beat centroid, and then we'll create a buffer car beat centroid for 0.33 mile, and then we'll create a buffer for retail businesses of 0.1 mile, and then we'll select the major streets, and then we'll create a buffer for that, and then we can intersect 2 buffers at a time, and then we'll come up with our zones where we can actually create this or have our new police station. So Let's get started. I'm gonna open my map document 9.2, and the first step is to open the car beats table and add a new field called X. Oh, it's locked. Let's try that again. Add a new field called X, and it would have a double for type, and I'm going to add one more field called Y, and that will be a double type too. Okay, so I'm going to right click on X and click on calculate geometry, and then I'm going to select X coordinate of centroid, and I'm going to click OK, and then I'm going to right click on Y field and calculate geometry and select Y coordinate of centroid, and we got our X and Y's. So we can use this to actually create our centroid layer. So how do we do that? I'm going to open the attribute table again. I'm going to select this table, go to table options, click on export, and then I'm gonna export this as 9 GDP. We're gonna export this as car beats centroids, perhaps. Save that, click OK. I'm gonna add that to the map. Now I'm going to right click on the car beat centroids table, and I'm going to click on display X and Y data. So I'm going to choose the defaults here, click on OK. So once I get that field, this is an XY event field, which means this is a temporary data set. We need to export this as, I'm going to export this as lake car beats. Yes, sir, pressed. I'm gonna call this as XY car beats centroids, and click save, click OK. Once that is in the map document, I'm gonna remove the XY event file, and then I'm gonna change this, give it a more prominent color and size so that I can see it clearly. Go back to the okay. Now that that's done, I'm going to create buffers, where I'm going to go click on Geoprocessing, click on buffer, and then I'm going to drag and drop my XY car beats into input features, and then export these as buffer car beat centroids. Buffer car beats centroids, save the linear unit. We know we are trying to create a 0.3 mile buffer from the centroid, which is what is required. And then I'm going to dissolve all, click OK. So once that process is done, it will be automatically added to the map, and you'll have a little notification saying it's been completed. So when you're creating this, make sure you have miles selected, otherwise your map wouldn't look right. So click OK, it'll be added to the map, and then you can change the symbology to something of your liking, perhaps green of some sort, and then the next step is to buffer the retail businesses. Since we already have the retail businesses in the map layer, what I'm going to do is click on buffer, I know the input features are, you can select from the drop down retail businesses. So 0.1 mile is the retail business. I'm gonna save this as buffer retail businesses. Buffer retail business. Click OK. You see what happened when I didn't select the dissolve all option? That's not the layer of what I want. If you open the attribute table, you have one buffer for each one of these, one circle for each one of these, which is not what I wanted. So I'm going to delete that, and I'm going to go back to our toolbox, double click on buffer. This time I'm going to save this as buffer retail businesses, to save, dissolve all, 0.1 miles. Click on OK now. So once you do that, you should have a 0.1 mile buffer around these retail businesses. I'm gonna select that, add a light outline to this. So I have my retail business buffer and my centroid buffer. All I need now is a major street buffer. So I'm gonna first go to my selection by attributes, a tool. I'm gonna select from the streets where FCC, which is the street type, is equal to so since I know that A40 or A41 are the are the major streets, since I already know that, I'm going to use them to actually create my selection for major streets. So let's see if those streets have been selected. Okay, the streets looks like they have been selected. So what we need to do is create a 0.01 mile buffer, or 0.005 mile buffer. So I'm gonna right click on this. So the next step is to actually create a buffer around this selection. So for the input features, I'm gonna select streets, and then I'm gonna save this as major buffer major streets, and then I'm going to select dissolve type as all, and then click OK. So again, the buffer is 0.05 miles, and then click OK. So it's gonna create a buffer around these major streets, which will look something like that. I'm gonna clear the selection, and then I'm going to apply a light green outline to this. So now we know that the station can be located within the combination or the intersection of all these three buffers. So what we do to actually identify that is intersect buffers. So I'm going to go to my arc toolbox. I'm going to click on overlay and intersect, and double click on intersect. I'm going to drag and drop my car beats and retail business buffers, retail business and car beats buffers. I'm going to save them as I'm going to save this as step 1 maybe, because I don't want to give it a big name. I'm going to use this step 1, and step 2 would be a combination of step 1 and intersection of major buffer streets. So I'm gonna use that and click OK. So let's add step 1 to the map. Okay, that's step 1. And now I'm going to go back to my arc toolbox. So this is a combination of car beats intersection and retail business intersection. So what we need now is that intersection, that combination of those two, plus we are going to overlay our major streets on top. Now I'm going to call this buffer suitability. For suitability, I'm gonna save it, click OK. Now what you'll get is the final selection just based on. So essentially you can turn off all the rest of the layers. You will get your the zones where you can actually have your police station set up. Now you pass this on to your real estate guy or the city department, asking them to find the right location within these particular zones. So that's how you actually go about finding a site. That's it. So let's talk about multiple ring buffer analysis for calibrating a gravity model. So I actually had to replace this 9.3 with this one, because the old one, which is apportioning data, which is not really that useful or not really that common, I decided to skip it so that we can learn something more useful and something more relevant. I'm gonna put these scanned pages on Blackboard, and I'm going to upload the GDB for the data so that you can do this analysis by yourself. So let's get started on 9.3, where the basic principle of gravity model is this. It says that the attraction between two objects falls off by the inverse of the distance between. So the attraction is inversely proportional to the distance. So the closer they are to a particular location, the more likely they are to actually go use that facility or use that location or go shop at that store. So the farther they are from that store or facility, the less likely they will be in using that. So in this exercise, what we are trying to do is sort of demonstrate this estimated fall off of attraction. So we need residence location of clients and data on target population so that we can perform this analysis. So in this case, we have a random sample. So the case study is this. We have some of the officials have to close the Pittsburgh pools during a budget crisis. So what we are trying to figure out is, did the remaining pools provide good access for the rest of the city's youths, and how quickly does the intended use of pools fall within the distance to the nearest pool? And owning a pool tag is what they give anybody who's a youth, who's considered is under that age group. You can apply for it, you can get an access to a pool tag. So owning a pool tag indicates the intention to use the pool. So that's the premise of the case study. So what we'll do is we'll analyze this data. We have pools, whether it's an open pool or a closed pool data, and then we have pool tags, and then we have Pittsburgh census block centroids, where we have they are actually on a monochromatic dot scale, scale where they are the darker they get, the higher number of youths or ages, population between ages 5 and 17 are present in that block group. So that's where that's the data we have. So what we'll do is we'll build multiple ring buffers around the pools. We'll intersect these buffer rings with a random sample of residences of youths. and what we'll do is sum the pool tags within the same buffers and see what percentage of youth actually are actually using the pool, and see if this since this is a multiple ring buffer, if this percentage of youths using the pool or have a pool tag decreases dramatically by the distance as they are located further from the pool. So that's the exercise, and then we'll plot the fraction versus average distance of the ring so that we can see this in we can prove this gravity model. So that's what we're gonna do. We'll create a distance, separate polygon for each of these buffer distances, like 0.25, 0.5, 0.751, 1.5, and 2 miles. So we're gonna create all these different buffers, and then we will essentially join the spatial join the youths with the tags, and then youth population with the buffer rings, and then we'll essentially get our end rate. We'll calculate use rate, and then plot this kind of a graph. So let's look at this exercise in action. So let's go to map document 9.3, sort of like 9.3 version 2 sort of a thing. So I'll provide this map as part of your via Blackboard. What you will do is, the first step is to see the pool tags. You see all the pool tags, those are all the people or all the youths that have pool tags. Okay, that's good. So what we will do now is we will create multiple ring buffers for open pools. So how do we do that? So I'm going to right click on pools or selection by attributes. I'm going to select by attributes where pools open is equal to 1. If open is equal to 0 would give you closed pools. So those are all the open pools. I'm going to right click and export these as data. Export these as, I'm going to create this in a new GDB perhaps. Tutorial 9.3. I'm going to export this as pool. We don't need to export these pools by themselves. I'm sorry, you can cancel this. I'm gonna go to Geoprocessing, click on buffer. The input features will be pools, and since we already we have an active selection, it's gonna only generate the buffers for the active selection. So I'm gonna one more thing, this is only for creating single buffer, so we need multiple buffers. So I'm going to go back to our toolbox, click on analysis, proximity. There is a multiple ring buffer script which I'm going to run. I'm going to drag and drop this pools into the input features, and then I'm going to save this as under 9.3. I'm going to save this as buffer pools, and then I'm gonna add my distances: 0.25, 0.5, 0.75, 1, 1.5, and 2. So those are my multiple buffers, and the buffer distance is in miles, and I'm gonna dissolve all. I'm gonna choose those options. I'm gonna click OK. So once that is done, we will change the outline colors based on just gonna give some hollow colors to this, just outlines, fill to these multiple buffers. So it's done. Based on your how fast your computer is, it might take you a little while to actually get all this done. So now I'm gonna change the colors here. Start with something like I don't know, dark green. No fill color, I'm sorry, just the outline, and change them to look something like this. So something like that. So when you zoom in, you can see that there is a gradual change of colors while as the buffer distance increases. So the next step is to spatially join buffers pool tag owners and then the youth population. So what we'll do is right click on buffer, go to joins and click on join, and select the second option from the what do you want to do, this layer option, and then I'm going to join pool tags, and I'm going to click on sum so that I can count the total number of pool tags within each of these buffer zones, and then I'm going to export this as join buffer pool tag. Join buffer pool tags. I'm going to save this. So just to make sure, I'm going to open my attribute table and scroll to the very end. So what I got is sum of tags. Oh, the count shows the total number of pool tags within each of these individual buffer districts. So that one has 259 pool tags and so on and so forth. So the next step is to join this one, spatially join the join buffer pool tags to the Pittsburgh block centroids, and then do the same spatial join again. This time what we are expecting is that the total number of youth population will be, the total number of youths will be attached to this individual buffer polygons, so that we can compute the use rate. So I'm going to save this as join buffer pool tags youth. So I'm going to click on OK, click OK. So this might take you a little while to complete this entire process, because let's face it, this is it could be intensive depending on how fast your machine is. So let's look at this the attribute table of the latest join we have done. So what I'm interested in is age. This one right here, 5 to 17, sum of age 5 to 17. So these are all the youths, and these are all this count right here is the total number of pool tags that you have within each of these individual zones. So So the next step is to compute the use rate. How do we do this? So I'm gonna right click on my join buffer pool tags youth uh, feature uh, feature class, and then click on add field. I'm going to add a field called use rate. I'm gonna make this a double float perhaps. Click OK, and then I'm going to calculate this use rate. So use rate is nothing but so like the instructions say, we will calculate the use rate using this formula where we use the formula 100 multiplied by 11.3, which is the scale rate, scale up factor for the from the sample. Since this is a sample of pool tags, it's not the entire data set, so we just used a sample, so we need to account for that. So that's the formula for that, and then we'll multiply that by count, which is the total count underscore, and then divide this by sum of age 5 and 17, which would give us the percentage of estimated percentage, you can say, of the use rate. Click OK. As you can see, the results are fairly obvious for the within the first buffer zone, which is actually 0.25 miles. If I move this to the very end, so you can clearly see that as the distance increases, your use rate decreases to about 41% from 87% within the first quarter mile. So that's the result we wanted to show to prove our gravity theory, so to speak. So we're going to create a scatter plot based on this. So what we need to do is before you do that, we need to create one more field called distance average, and call it and make it a float. Click OK. So just make sure your table looks the reason we do that is even though this is 0.25, the average is between 0 and 0.25, which would give us 0.125, so on and so forth. So I'm gonna just go ahead and add all those distance average values into the table by right clicking on this, clicking on edit, start editing, and I'm gonna keep typing 0.125, 0.375, 0.625, 0.875, 1.25, and 1.75. so that will give us the average distances instead of actually the absolute other end of the spectrum. So we're going to use this to create our scatter plot. I'm going to click on editor, stop editing, and then turn off these two layers, but I'm going to click on insert, go to graphs, under view, create a new graph, and then I'm going to use a scatter plot, and then the Y field will be use rate, the X field will be the distance average, X label field will be distance average, and then the vertical axis is left. So we don't need the legend, so I'm just gonna turn that off, and then I'm gonna if you want, you can show labels, perhaps click on, if you don't want to show labels, that's fine too. Click on next. Click on next. So that's the graph we are interested in, which shows that as the distance increases, the percentage of pool tag owners decreases, or in theory, this proves our gravity theory. Okay, so that's your exercise 9.3, and good luck with your assignments.